Welcome to this session where we are going to look at power in physics. Let's start. It's a very simple topic of which we are going to cover in a very short period of time. Let's start by defining what power is. Power is not energy. That is one thing you need to understand. Power and energy are two different things. We define energy as the ability or the capacity to do work, but the rate at which work is done, that is what we call power. So what is this power? Power is the rate at which work is done or energy is dissipated. So it is just the rate at which work is done or at which energy is dissipated. That is what power is. So how can you summarize this? How can you illustrate this in a formula? So we're saying power will be equal to work done. You see, whenever we talk about rate, it is something to do with time. So divide by time taken. So this is power. Power is equal to work done divided by the time taken. That is what power is. But from what we discussed earlier, we said that work is equal to force times distance, right? So work is equal to force times distance. Then, since we are talking about power, it will be over time. So power can also be given by the formula force times distance over time. So let's try to understand something here. So we are saying power is equal to force multiplied by distance, right? Over the time. But force is given by the formula mass times gravity, acceleration due to gravity, right? That is the force. So we can say power is equal to, where there is force, we substitute mg, then multiplied by d over time. So this is another formula you can use for power when you have mass, gravity, distance, and also the time. Let's look at, with respect to energy, how can you define power? So power is just the rate at which energy is transferred. So power is the rate at which energy is transferred. So we're going to say power is equal to energy. When you're talking about rate, we've said it is time. So power is equal to energy over time. The energy transferred divided by the time taken. Let's look at another formula which we can use in order to calculate power. So from the previous formula, we said power is equal to the force multiplied by the distance, right? But we can calculate distance as the average velocity multiplied by the time taken. This is how we calculate distance, right? So we can even say here that power is equal to the force multiplied by, what's the distance now? Power is equal to force times distance over time. So the distance is now average velocity multiplied by time divided by the time there, the time which is there, because power is equal to force times distance over time. So this is the time. Then this time and time can cancel out. What are we going to remain with? So we are going to remain with power is equal to force times velocity. Force times velocity, and this velocity must be the average velocity. average velocity. So we can use also this formula to calculate power. Now let's look at the units for power. From our discussion, we've said power is equal to work done. Power is equal to work done over time, right? Work is calculated in joules, over time in second. So we can see that power has the unit joules per second. So 1 joule per second is what we call a watt. So what is a watt? A watt is just a joule per second. You get? So a watt is a joule per second. That is what we call a watt. So 1 joule per second is equal to 1 watt. So we need to also understand what about if they say a kilowatt. So a kilowatt is just kilo means 1000. So 1000 watt. Okay. There's also what is known as a horsepower. There's also what is called a horsepower. So here we just need to know the conversion. When you're converting from maybe horsepower to watts, okay? So 1 horsepower is equivalent to 745 watts. Okay, that is a horsepower. So you need also to understand what it means by a horsepower. It should be 745. Yes, that is, if not mistaken. But don't worry about the figure. You'll be given to be provided. The conversion factor will be provided in the question paper. So you just need to refer to it. There is no need to master it. Okay, but it's around 740 something, 745, somewhere there. All right, so now at this point, let's look at an example. Let's say let's say a man lifts a bag of cement upward. Ten meters upward in 2 seconds. So what is the power? So a man lifts a bag of cement of mass. We've forgotten the mass there. So of mass 1200 kg. Okay, that is the mass. Upward 10 meters in 2 seconds. So what is the power? What is the power? So take gravity to be equal to 9.81 meters per square second, right? So how can we calculate this question? So we are going to use the formula which we've talked about. So what we have, we need first to correct the parameters. Data: a man lifts a bag of cement, that is 120. So what we are going to say is mass is equal to 1200 kg. Then what else do we have? The distance distance is equal to 10 meters. Then in 2 seconds, time is equal to 2 seconds. Then what else do we have? Take gravity to be that. So gravity 9.81 meters per square second. So how can you calculate power? So power, we've said P is not the symbol for power. P is for momentum. So power is equal to, since we have this, we have the mass. So power is equal to work done. Work done over time, right? But work done is force multiplied by distance. Then it will be over time. But force is equal to the mass multiplied by the gravity, then multiplied by the distance there, the distance we have, then over time. Okay, so we need just to substitute. So let me get rid of this part. So our power will be equal to mass, it is 1200. What is the gravity? 9.81. What is the distance? The distance is 10 meters. So multiplied by 10. What is the time? It is 2 seconds. Make sure that all the units are in SI units. Okay? So I'm just going to say 1200 multiplied by 9.81. Then multiplied by 10. Divide by 2. So it is giving 58,860. What are the units? Watts. So this is how you can. So what if they said in kilowatts? How can you write the units if they told us to write the units giving the answer in kilowatts? So you can just say, we can just convert this in kilowatts. We have 58,860 watts, right? So we multiply, we use dimensional analysis. We multiply, we want kilowatts. So kilowatt will be there, then watt will be down so that it will be able to cancel. So 1 kilowatt is equal to 10 to the power 3 watts. A kilo means 10 to the power 3. So a watt and the watt will cancel out. So what they simply mean is that divide the answer by 1000. And we'll be able to get 58.86 kilowatts. So this is how you can find power. Let's look at an example whereby you've been asked a woman pushes a drum with a force of 500 Newton. At 20 meters per second. Calculate power. So find power. How can we answer this question? So let's solve this question. So for this one, we are going to say we collect first the data so that we know what we have and what we don't have. So from the question, we have the force of 500. So the force is equal to 500 Newton. What else do we have? The velocity is equal to 20 meters per second. What is our power? So power is equal to, for this one, we use the formula power is equal to force times velocity. So power will be equal to, the force is 500 Newton. The velocity is 20 meters per second. So you just multiply. What will be our power? So 500 multiplied by 20. So that will be 10,000. And power is measured in watts. So that is simply the answer, 10,000 watts. So this is how you can navigate around questions on power. So the most important things, know the definition, know how to apply the formulae in solving questions. If you are able to do that, then you are safe and dry. Thank you for watching. If you found this video to be helpful, don't forget to like, share, comment, and also subscribe. Hit that notification button so that each time we upload a new video, you're able to watch and not be notified. Okay, thank you.